I'm going to have to move through this pretty quickly, but it's about integrating field sampling and analysis and what we did in South Australia quite recently. And rather than, I'm just going to show a movie of it. Hopefully this will work. But we used helicopter-based sampling because it was a culturally sensitive area. But here I've packed 10 minutes worth of work into about 20 seconds. Field team of 3 people. 2 people are collecting soil samples and lag. Another person's collecting 2 different vegetation types, and both people, 2 teams are taking notes about the materials. So in that 20 seconds, or 10 minutes, and that includes the flying time, there were 5 different sample media collected at that time. All of those were georeferenced. They had information about the landscape, the regolith types, a whole range of extra little bits and pieces that you would normally scratch down. And we did that because we wanted to make this as fast as possible. We used QR codes, and I'll come back to those, I think, and you can see some of those on those sample bags there, where we were scanning information straight into the mobile field app, which is running in the background on all these little tablets. And that enabled us to get a lot of information very quickly. So for this thing, I guess it was a regional characterisation program, we were able to cover in about 4,000 square kilometres on the standard regional geochemical survey sort of thing, 4-kilometre spacing in a week. So as I mentioned, 6 minutes per site plus travel and refuel time, so about 10 minutes per total site. And most of this was done because we had IGSM, which is a geological sample number, could be anything, but it's a unique identifier that future-proofs tracking that information down globally. And then the other thing was the FAMES app, which the acronym is some sort of field information management system. But it involved things like sample scanning, bringing in a lot of information very rapidly and getting your GPS coordinated as well. And that's then backed up to a server. Either the server wasn't on the helicopter, but it could have been, and so we were capturing that data very quickly and then ingesting that. And that was probably the real power, is that by the end of the evening, 3 minutes, we had all the data from the field and we were able to use that. So that was the field side of things, and the benefit, just to sort of show you the numbers behind this, the project was about $300,000 worth of effort. The sampling time we cut down from 15 minutes to about 6, so it's a big saving in terms of running a helicopter for an extra week and a half. Another thing, data handling, I mentioned, I hate manually typing in numbers, so to be able to just take all that information and rapidly have it at our fingertips in spreadsheets was beautiful. No missing sample sites and data, so this was important because the helicopter, even though they were good operators, they knew where they were supposed to be going. Sometimes they flew their lines this way and went back this way and left a spot in the middle. But we were actually able to sit down and within that night, while I was sitting around the camp, say, oh, we missed one of our sites, and go back and get it. In a traditional sense, we'd never get that opportunity until, a month later when we're sitting in our Perth office going, oh, why didn't we collect a point here? So that was a valuable exercise. And then I'll show some of the machine learning aspects where we think we could reduce our sample numbers by about 50% in this case quite comfortably, and that's a big saving. And then the other thing was the lab-based, or the field lab, where we were able to produce portable XRF analysis, and thanks to the previous speakers that have sort of highlighted some of the key things you need to do to get good quality analysis, but we're able to do that as good as the lab quality data for the major elements. And because of that, we were able to do infill sampling. So not only were we able to collect our large area sampling, we were able to infill on a 1K spacing, make that decision while we're in the field, and then follow up, which was a big saving in terms of remobilisation. And just back in the lab, so we had 3 people out in and the pilot out in the helicopter. Back in the lab, we had this basic setup. All we had was power, really. The desk happened to be in this shed out in the Nullarbor, but we had portable little tables. You've got 1010 on the left there, is using a splitter, a mobile mill and crusher, and then I'm using the pallet press. These are the reflex instruments, but there's other pallet presses out there. And then Dave on the right of screen has got, you can see there's little laser scanners there for sample tracking and essentially like a checkout, blipping in samples, and then he's got portable XRF running and an analytical spectral device, a FieldSpec Pro in the cardboard box. And so that enabled us to get that information very quickly, so 24 hours behind the field sampling team, or less. In fact, it was only about 3 hours behind on the last day. There was a lot of things that went into the background to doing this before we got out there. So we had good operators setting this up before we did it. We did we did some field trials down in Byford, of all places, to test the techniques. the calibrator was something that's really great. There's an email address you can email in your raw XRF data and get it calibrated through CSIRO now. It's just coming out. But yeah, we had matrix match standards as well. We had local samples that we were using as standards. So there was a lot of good things to give us some really good quality data, and some of the previous speakers have touched on those. And then on top of that, we had a machine learning model, and I'll get to that in just a minute. And so we were generating these maps as we were going, and it was really powerful in terms of we're sitting around the dinner table at the end and talking about the maps we were generating and understanding things about that area before we even got back. And, you know, back in Perth, I would have been looking at it going, oh, why is that, you know, high down in the southwest? We already knew that because we were talking about it in the field. Unfortunately, you know, copper in the field, not so good with the portable XRF and the limitations of detection. So those are still ongoing issues, but the detection's going to get there. We've seen already today that we're improving all the time. So these sorts of workflows will work in the future for field analysis. And the other thing that we had was quite powerful. We had the ability to use all this data together. We often collect a whole lot of data and we look at it individually, but we're able to actually evaluate that as one. And the most powerful part is that we had uncertainty coming through with that in the model. So we're able to look at our maps and go, oh, well, you know, the computer doesn't quite understand. And you can see, I'll just try and get a laser pointer up here. You can sort of see as we're going, this is the first day of sampling. There's a line or two of the samples along the bottom. And the model's saying, well, I don't really understand the estimation. I think that's calcium there. And you can see that reflected in the uncertainty. The darker colour's less uncertain. As we progress our sampling, you can see the uncertainty's reduced. Those aren't on the same scale. And there's features there that we don't quite, you know, the model's saying, oh, it's still uncertain. And those are like regolith mapped features. So obviously we either got a lot of variation in the couple of points we had there, or we didn't sample a lot of that regolith type. And so there's a whole lot of information that's running in the background, actually 160 different bits of information. 40 of those are the PXRF elements. We didn't actually run the ASD proxies in this model, but a lot of that is ASTA data, regolith maps and models, the stuff that you have at your disposal before you get in the field. And this is just sort of showing how we can use that information better before we get to the field to maximise our sampling plan. With the machine learning, there's a lot of different options out there. And I think we'll become more comfortable with these. Most of them are much of a muchness. So we used a Gaussian processor regressor, but I think the next time we do it, we'll be using something different. And again, it's about having good people on board at the start to make sure you just set it up right. But it's actually quite easy to use. And I think in terms of future application, we'll be getting away from grids, and what we're terming that is active sampling. It'll be much more dynamic, so the information that's coming back to us will be just changing the way we do our sampling. So we won't be just stuck to a grid and saying that's our plan. And that for, you know, seeking out anomalies, that might be really valuable in terms of targeting on one field trip. There'll also be a range of different other algorithms feeding through where you can see, you know, you might be able to getting ranked targets as you're going along or something like that, and you can change and infill. And that's the demonstration of our infill sampling there, where we ended up doing 1 kilometre spacing on the last day. And just overall, I guess, in terms of exploration culture and where I think things may change, and it doesn't change quickly, but I think grid-based sampling is something that looks good, makes us feel nice when we see a nice filled-out grid, but actually we're not getting our maximum value out of the data that we already have at our fingertips before we get to the field. So I think you know, I'm keen to see us move away from grid-based sampling and use things like uncertainty to provide information into your sampling model. And so we also know that we can use, oh, I missed that on the last slide, but you can sort of see this is the example down the bottom where we didn't do this in the field, but we could have collected 50% of the samples and pretty much generated most of those same mineral maps that we had, or element maps, using the portable XRF chemistry. So we didn't need to collect the 300 odd samples. We could have done it quite easily with less. But if we'd used the model correctly, we would have informed our sampling locations as we went along, and it would have told us essentially we're pretty much at that point where you don't need to collect more data. And this comes back to the things I've also talked about, merging data types and evaluating separately and not just sort of drilling the biggest numbers. I think early on there's going to be user issues, so trust in some of these machine learning algorithms is still an issue. You still need people to look at that and make sense out of it, but I think there's definitely a lot of smart people out there that can use these things and use them very effectively, and I would encourage the exploration industry to dip your finger or dip your toe in the water, contact people that sort of are working in this space, because yeah, when things are good, you're too busy to improve, but you should be relying on the support around you of other research organisations and things that can and consultants that have these people in their background to turn this into your future sampling strategy. And I think that's it. Thank you.